So for number 2, we're taking the propositions in exercise 1, which I've put here, and we're writing a useful denial and giving a translation into ordinary English. So let's write the translation into ordinary English first of the denials, right? And before we can do that, let's just remember some things on how to deny. So whenever I have a universal, so for all x, p of x, the denial is just saying, hey, there exists at least one that such that not p of x. And then when we have an existential, when we have there exists one x such that p of x, the denial is saying for all x, not p of x, right? You can't find a single case. And then we also just have to remember De Morgan's laws that when we have not p and q, this is equal to not p or not q. And then when we have not p or q, this is not p and not q. So we are ready to start. So A, we're saying not all precious stones are beautiful. And this is actually saying there exists a precious stone that is not beautiful. So we're denying an existential, and therefore we're using the universal because we're denying an existential. So since we're denying existential, we go, let's see. Let me just fix this. I have to fix my font here so that you guys can see. All right, so we're saying A, all precious stones are beautiful, right? Because we're saying, because previously we had an existential statement. Okay, so let's do B now. So B, we have all precious stones are not beautiful. So we're dealing with a universal, right? So to deny a universal, we are going to have an existential. So we're saying there exists a precious stone that is beautiful. That is beautiful, right? So we're saying there exists an x such that not p of x, or p of x was not beautiful. For C, we have some isosceles triangle is a right triangle, so we have an existential, right? And to deny an existential, we need to use the universal. So we're saying no isosceles triangle is a right triangle, because now we're saying for all the triangles, right, none of them have property p of x, with p of x being right triangles. So for D, we have no triangle is isosceles, so we have a universal statement, right? So to deny a universal, we just are going to use the existential. So there is some right triangle that is isosceles. Okay, for E, we're having universal, because we're saying all people are honest or all people are dishonest, right? So to deny that, we just need to use the existential. There exists, for this one, we're saying there exists people that are honest. And because we have the or, now the denial has the and there exists people that are dishonest. So because our original statement had an or, we are going to use an and. For F, we have some people are honest and some people are not honest, right? So here we have the existential. We have existential, conjunction, existential. So we're going to do universal, disjunction, universal. So we're saying all people are dishonest, or all people are honest. Okay, that was our F. What about G? So G, we're having a universal, because we're saying every integer greater than -4 is greater than -4 or less than 6. So because we're using the original had the universal, we're going to use the existential to deny. So we're going to say there exists an integer this is not letting me write n. So there's this integer such that the opposite of greater than -4 is less than or equal to, such that it is less than or equal to -4. And because our original had an or, our denial is going to have an and greater than or equal to 6. Yes. So that is our G. What about our H? We're saying every, no, that was our H. I missed an example, so let's put in our G. So our G is every non-zero real number is positive or negative. So once more, we have a universal. So we're going to say there exists, we're denying it with the existential, a non-zero real number such that it is the opposite of positive is non-negative, right? Actually, yeah, the opposite of positive is not positive, sorry. There exists a non-zero real number that is not positive and not negative, right? We had a disjunction, so our denial, we have a we'll have a conjunction. There's a, yeah, that is not positive and not negative. Okay, let's do I now. So I, we're going to have every integer is greater than some integer, right? So universal, so we're going to use the existential. There exists an integer, we are at I, that is not greater than an integer that is not greater than, let's see, that is not greater than every other integer. So the other way, actually a more clear way to say this is there exists a smallest integer, because that's a different way of saying there exists an integer that is not greater than every other integer, right? So that means that it's the smallest. And for J, we have the denial of there is a smallest positive integer. Oh, sorry, for J is no integer is greater than every other integer, right? So for this one, the denial is some integer is greater than every other integer. So for the denial of this is J, there exists a largest integer. Okay, that was fairly straightforward. For K, we have between any integer and any larger integer, there is a real number. So denial is because any is universal, so we're going to use the existential, right? So we're going to say there exists is this integer x, and there exists integer y such that there is no real number between them. We did K, and now we have to do L. So for L, we are going to do, let's see, there's the smallest positive integer, right? There is existential, so we're going to use the universal to deny it. So we're going to say for all positive integers, there is a smallest, yeah. For all positive integers, there exists a smaller positive integer. So we're saying, there exists a case for an L that is even smaller, right? So that means that there is no smallest And let me scroll this up so that we have more space. So we did L. For M, no one. This is a universal, so we're going to use an existential to deny it. So there exists someone that loves everybody, right? That is our M. What about our N? Our N is everyone loves somebody. So that is universal. So we're going to say there exists someone that loves nobody, right? So we just changed the universal to the existential, and then we denied the proposition. And lastly, we have O. For every positive real number x, there is a unique real number y such that 2 to the power of y is equal to x, right? So we're going to say now, for every, since this is universal, we're going to use the existential to deny. So we're going to say there exists a positive real number x, for which, right? For which the opposite of there exists a real number y, since this is existential, we're going to use the universal. For which, for all real number y, there exists no unique solution for 2 to the power of y is equal to x. Yeah. So we basically said, since we began with the universal for every, we said there exists, right? And then we had there exists a unique real number y, right? So we're saying that for all real number y, there exists no unique solution for 2 to the power of y is equal to x. All right, that is our denials, the translation into ordinary English, and now we just have to fill in the symbolic denials. So for A, all precious stones are beautiful. What we're going to do here is we're going to go, so for all x, we're going to say if x is precious, right? If x is precious, then x is beautiful. And that is usually, we use the conditional to express the universal. Now there exists, so we have there exists an x such that it is, if x is precious and it is beautiful, right? So x is precious and x is beautiful. X is beautiful. Okay. For C, we have a universal. So we're saying that for all x, if x is isosceles, right? If x is isosceles, oops, I wrote isosceles. So if x is isosceles, then it is not a right triangle. Okay. D, we have an existential, right? So there exists an x such that x is a right triangle, and x is isosceles. Let's see. Yep, that is correct. For E, we have the existential, right? So we're saying there exists x such that x is honest, and there exists people that such that x is dishonest. Okay, so F, we have a universal, so we're saying for all x belonging to people, right? Either x is not honest, so either x is not honest, right? or for all x, x is honest. Now, it would be a mistake to say for all x is not honest, or x is honest, because then it's like, well, clearly someone is honest or not honest, right? That would just be a tautology. So we have to make sure to separate these statements in saying for all x is not honest, or for all x is honest. Now G is existential, so we're going to say there exists a non-zero real number, right? So there exists, for G, an x non-zero real number. X is not equal to 0, such that, we're going to say that x is not positive. So for x to be not positive, it is smaller than equal to 0, and x is not negative, right? So x is greater than or equal to 0. H, we have existential, so there exists an x. There exists an x, so we're saying that x is an integer, right? So x belongs to the set of integers, and we're saying that x is less than or equal to -4, less than or equal to -4. And we're saying, let's see, what else are we saying? And x is greater than or equal to 6. Okay. So we're saying there exists a smaller integer, right? So we're saying there exists an x such that for all y, x is smaller than or equal to y. And J, we also have an existential, so we're saying there exists an x such that for all y, now we're saying that x is greater than equal to y. So there exists an x that is, greater than all y. So that means that it's the largest. For K, we're saying there exists an integer x and there exists an integer y, right? So here there exists an x and there exists a y, such that x and y belong to the set of integers, and there's no real number between them, right? And I should have written there exists an integer x and there exists an integer y, such that I forgot to add that x is less than y, right? I forgot to add this. So we're saying there exists an x and there exists an y, such that x and y belongs to the integers, and x is less than y. And we're saying, and there's no real number between them, right? And since we're in the universe of real numbers, and for all z in the real numbers, we're going to say for all z, if there's no real number between them, then we have to say that there's a contradiction, right? So I'm going to say x is greater than or equal to z, which is greater than or equal to y. So for this one, because x is less than y, it can't be, right? Actually, this maybe is a confusing way to say it. So, and there's no real number between them, right? And we're going to say, and there does not exist a z such that x is less than z and y. Sorry, I should have put this z, then y. So we're saying x and y are integers and x is less than y, and there does not exist a z such that z is between them, right? And then I just have to put a parenthesis here, yeah. And then for L, we're saying for all, so universal, for all positive integers. So for all x, there exists, right? There exists a y such that, we're saying here, such that y is less than x, right? Oh, but we have to indicate that they're positive integers such that, so we're saying x and, xy belong to the set of positive integers, so we denote this with a plus. And y is less than x. So we're saying for all x, there exists a y that is less than x, right? So there exists the smallest one. M, there exists someone that loves everybody. So there exists an x such that for all y, we're going to say that x loves y, right? So there exists an x that loves everybody. And here we're saying there exists an x such that for all y, someone that loves nobody, right? So x does not love y. And lastly, we're saying there exists a positive real number x. So we're saying there exists a positive real number x. So there exists a positive real number x. X is greater than 0, and such that for all real number y, there exists no unique solution, right? So such that for all real number y, there does not exist a unique solution for 2y is equal to 0. Let's see if this made sense. That is 3 parentheses, yeah. So there exists an x such that if x is greater than 0, and for all y, there does not exist a unique y such that 2y is equal to x. Yep. And that is it. That was a long video, but hopefully you guys got to see everything. I'm just going to zoom out so you guys can catch it all.